Hello and welcome to this ninth part of video on Python Standard Library. So special welcome to those who are new to the channel. So we are studying the Python Standard Library. This is part 9. The first function which we are going to study today is odd function. Now what odd does is it takes one Unicode character as input. For example, I have given A and euro sign. So the input which it receives, the character which it receives, it converts that into a Unicode code point of that character. So it will convert A and euro into Unicode and print that because we have used the print function. So let's see this in action. Python lib9.py. So A has an ordinal value of 97 and not ordinal value, it is the Unicode code point, and 8364 is for euro symbol. So it is not very useful, you don't use it in common day-to-day practice. It is just for the completeness I am presenting it. Next function is pow, or full name is power. So it computes the power of base to the power exponent. It is equivalent to base to the power exponent. This is the operator which we use. This is the power operator. So for most cases it is the same thing. So we remove this. So first we have 10 to the power 2, which would be 100. Then we have 10 to the power minus 2, which would be 0.01. Then minus 10 to the power 2, which would be again 100. And then we have minus 10 to the power minus 0.5. Now this is a special case. It says in the documentation, for a negative base of type int or float and a non-integral exponent, a complex result is delivered. For example, minus 9 to the power 0.5 returns a value close to 3j. So you'll see this when we run this. So we have 100, 0.01, 100, as we discussed in 3 cases. For the fourth case, you will notice that the real part is 1.936 and so on e to the power minus 17, which is really small. And the second part is close to 0.3. So if we give it minus 9, it would be closer to 3. So it is 0.333 and so on. So this is how the power function behaves. Now there are other cases as well. The third argument is the modulus argument. So for example, if I give this and I give 3 here, let's just look at this. If I give mod as 3, as you can read here, for int operands base and exponent, if mod is present, mod must also be of integer type and mod must be non-zero. So if we print 3, then 100 by 3 would be 33 and remainder would be 1. So modulus should print 1 in this case, which it has printed. If we give 6, then 16, 60 and 96, modulus should be 4. So for normal values it works that way, but if mod is present and exponent is negative, base must be relatively prime to mod. In that case, power of inverse base to the power minus exponent comma mod is returned, where inverse base is an inverse to base modulo mod. So what this means is, suppose we have this, okay, 38 is the base, minus 1 is exponent and mod is 97. Then in this case 23 would be returned. This line will return 23 and 23 into 38 modulus 97 would be 1. So let's see this. So it prints 23 and modulus I have printed, I have tested for equality. So let's see this. It prints 1 for the modulus. So our assumption is, or our calculation is correct. Next, we have a very common function, which is print function. Print takes a sequence and an optional separator, an optional end line character, a file to which print to, and flash. So for example, if we print 1 2 normally, then the default separator is a space. It will print 1 space 2. But if you want, you can use a custom separator. Okay, for example, if I want, I can give it a separator, say $. So both will be separated by $, as you can see. It can be a string also. Okay, I can say yuan or say dirham. Then it will print $1 Now ending is by \n. That also we can change. We can say that end is equal to e. Then it will not print a new line. See, this prompt started on a new line, but this prompt did not start on a new line, and we have e at the end. In general, it is not a good idea to do this. And separator also, usually you don't want to touch it. The file can be a text file. Print can print to a text file. The default value is sys.out, std out, not out. So you can import sys here. I'll print to that. You can print to a file, but you have to open it first. So for example, I can say open x.txt, or let's call it tmp.txt, comma. Let's open it in write mode. Okay, so this will be a text file in write mode. Let's check if we have tmp.txt. We don't have it. Okay, and we now give it a descriptor f. So we print to this and we see what happens. We should close the file also. Okay, so let's run this. Now we see tmp.txt. You see it has printed to the file. Print should not be used to print two binary files. It will not work properly. Okay. The last argument is flush. I would suggest that you leave it to its default, because for files, text files, you can set to line buffering, as we discussed yesterday when we were discussing open system call. So for text files, this you can set to line buffering, but in general it is not recommended to touch this. So most useful arguments in this case are file, separator, and your arguments. You can also print formatted strings in print. So there are many ways to print a file, print a line, which we have discussed earlier also. Now we will look at a property keyword or property function, or a property object, however you want to call that. So for example, we have property. So it's an attribute. Okay, property is an attribute. Now it's an attribute of what? It's an attribute of a class. Okay, so there are several functions which are used to manage this. First one is fget, which is a getter. Fset is a setter. Fdel is a deleter, and doc is docstring of that. So let me bring some of this code above it for convenience. So we create an object c. Now we can set it like c.x is equal to 5. It will implicitly call this this guy setter. Okay, because x is a property. So if you try to set x, it will implicitly call set x. So we can test this whether set has been called or not by calling this guy setter called. Okay, now we print this also, and this c dot x we can print, and then you will see that getter is called. So these are predefined names of the functions. Okay, and then we print this, and then we can print, we can call hello help on c dot x, which should give us I am the x property, and then we can delete this also, del c dot x, which should invoke the deleter. Print deleter called. Let's see if it works this way. So yeah, our setter is called, getter is called, 5 is printed, then getter is called again. So here setter is called, here getter is called, here again getter would be called because we are invoking c dot x. Okay, and then eventually finally deleter is called. So let's run this again. So it prints help on integer object. Why it printed help on integer object? The reason for this is we have assigned an integer. What if we assign c to itself? It would be fun, right? Okay, let's see that it would. So now we are looking at functions class C's help file, you see. So now it prints that 5 is basically a C object, and finally deleter is also called. So these functions work for this attribute x. Okay, similarly there are decorators set for this. Okay, predefined decorators. These decorators are appropriately called getter, setter and deleter. There is no decorator for docstring. So if you rerun this example here, it would behave in the same way. Now the next next function which we are going to deal with is called range. Range we have already studied earlier also, but let's revisit this for the sake of completion. So range takes a left start argument, takes a stop argument, and step is optional. So we can say for I in range, let's call it R. For I in R, print I. This will print from 1 to 9. Range is a half open, half closed interval. It is half closed on the left side, that is it will start from 1 and it will end at 9. So it is open on right hand side. It prints 1 to 9. Now if you want to give it a step, we can say 2. Then it will print 1, 3, 5, 7, 9. You can give a step 3. It will print 1, 4, 7 and so on. So the step could be negative also, but in this case it won't print 1 to 9, or it won't even print 1. Okay, the reason is the step when applied to start is less than the start, while it should be greater than start. It should go towards the stop. When step is applied to the start, it should go towards stop. If it does not happen, then it won't print anything. But you can definitely go negatively. From 0 you can go to say -9, for example, like this. Oh, the default step is 1, so step should be in this case -1. Okay, step is not needed. So see how it goes towards negative. So if stop is less than start, then step should be negative because the default step is 1. So in this way you can go forward and backward. And range is quite efficient in Python 3 compared to Python 2. In Python 2, range was used to be very inefficient. It used to generate all the values in the range at the same time. And there was an xrange method which would give you a generator. So in this case, range is a range object which produces value one at a time. It does not hold the entire list in memory. So with this, we come to the end of 9th part on Python standard library. In the next video, we will study more functions of Python, more built-in functions of Python. We have a long way to go in standard library. It will be a lot more videos before we reach then. If you have found this video useful, please subscribe to the channel, like the video, share on social media, and speak your mind using the comment box. I would like to interact with you people, with my viewers, so that we can exchange ideas and discuss that what other things we could cover. For example, in Python, it's very popular for web development, so I would like to cover web development. AI, I wouldn't want to touch first because there are lots of prerequisites for AI which I have not covered. So first I will like to cover those AI prerequisites. Then possibly we can go into AI. The prerequisites are multivariable calculus, statistics, probability, linear algebra, those kind of things. So once we cover the mathematical aspect of it, we can go into AI. Similarly, when you talk of AI, when you talk of images and sound processing, you should know signals and systems, the transforms associated with it, and so on. So let me know in comment box if you want to see videos on such topics. And once I finish Python, I will definitely cover those topics. Thanks a lot for watching. Happy programming.